All right. Okay. Thank you for the kind words. And thank you, Ms. Fair, for providing this opportunity. And thank you, ICMDIA 2025 committee. Without further ado, let me share my screen, start my presentation. Please let me know when you can able to see my screen.
Yes, sir.
Move this here. All right. Today we are going to talk about shift left strategy. Shift left strategy is kind of related to every different area of software engineering field. Today we are focusing mainly on app security and quality of the software. And how the available AI tools going to help us to achieve this in AppSec by design strategy. Today agenda, we're going to cover the application cybersecurity, some basic definition, what does it do, and application security, security testing, what are the different types of security testing we have, and the conflict between the very important thing, time and quality. Whenever we try to make it faster, we try to tend to cut the corners, reduce the quality. Whereas when we go for very detailed quality-based application, it takes more time. And how to right balance, that's going to be discussed. Why shift left strategy is not negotiable? We are going to see it. And in addition to that, commercial AI options available in AppSec and vision and future for this. All right. So first, some basic definition. Without knowing the thread, without knowing its scale of the thread, it's almost impossible to defend it. So let's talk about the threats and the existing framework available to prevent it. So basically, like the application security or the system security can be classified in two different higher categories. One is application security, and another one is cyber security. And the responsibility for application security is developer and DevSecOps, and more of looking into the code vulnerabilities and making sure like the tools are leveraged in the software lifecycle, like static dynamic analysis tools. That's part of application security. Whereas when it comes to cyber security, it focuses on more of threat to data and infrastructure, and tools like firewalls and intrusion detection, those kind of the tools we will be used there. And the responsibility for cybersecurity is cybersecurity operation and IT admins. With that, so let's talk about open source software. Today, the statistic says approximately 90% of the code running in the production are from open source origin. So why open source? Open source is free and fastly evolving, and we can contribute, we can take it without any additional licensing cost. And more on top of it, like because it's open source, many people contributing, and there is no need to wait for kind of major release from a private sector. And value of open source software is estimated 8.8 trillion, which is if this is kind of country's economy, it will be the top third position in the world. And the scary part is, doesn't matter like it is open source or not open source, most of the hackers need 5 years or less to exploit a weakness once found. Just 5 years. And the another challenge here is, because it's open source, anyone can able to contribute, anyone can able to publish. There's a risk of state-sponsored cyber attacks represents a substantially greater threat to a nation or an organization security than hacktivist style attacks. For example, college kids trying to are going to attack something, like I'm going to try this, more than that. Okay, if you see it, not only did COVID pandemic impact economy, but vulnerable software in production can cause similar damage to a country economic if it is not taken seriously. Let's think, there's a big financial institution. If 3 of them compromised, major 3 financial, one, even not 3, just one financial institution compromised, And that should be enough for a country's economic to get impact. And the software size, if you see from 2018 to 2023, the number of downloads, it's rapidly increasing, meaning like people are using it, growing forever, right? So this to just give a background of the issues with the size of open source software and how and its scale. Okay, now here. So what happened, like, apart from impact, like what are the consequences of non-compliance? And in order to make it the software system tool safe and secure, there are so many compliance agencies, regulatory bodies, government, and semi-government organizations are enforcing so many regulatory guidelines. And every software you know uh, industry or company need to comply when they touch with kind of a PA data, healthcare data or fintech data. There's some compliance you don't need to. So what are the consequences the when the system is not compliant? The first thing, business disruption. Let's say if there is a company, if that came out as a news, like so data is no more safe, and definitely it will impact the business disruption. And obviously cyber attack and operational shutdown. Let's think about a simple thing. We are using email every day and day out. One of the major email provider, let's like our software is compromised, our system is compromised, and the system is attacked. Your data is no more secure. Think about that, like how serious it would be. And obviously, not just people, the users will get impacted, but also the business itself get disrupted. Obviously, revenue loss of trust, reputational damage. On the other hand, apart from this, legal and litigation costs. Next slide, we are going to see the kind of very high level of what will be a litigation cost, or the penalties if you are not compliant with the provided guideline by the regulatory bodies. And class action lawsuits, obviously, like civil litigations, failure to meet standard, unwillingness to partner, and loss of business opportunity. These are the different consequences. Needless to explain every item. And here are the kind of, I would say, top 5 regulatory bodies providing guidelines how to secure what need to be taken care when you're handling healthcare, PI, and financial data. GDPR. If GDPR is not compliance, if they found there is a violation, they can fine up to 20 million euros or 4% of annual turnover. HIPAA, it can be a incident per $100 to $50,000. Think about this, like when you say incident, like multiply by number of users attached to the system. An annual cap is 1.5 million annual cap. And CCPA, $7,500 for intentional violation. Let's say if there is a guideline given, like you need to take care of this, if the organization not prioritized it and try to do it later or try to avoid it, this is the cost they need to pay. And PCA, payment card, industry, $5,000 to $100,000 per month. Let's say if the PCA found, the right regulations were not followed for like 5 months, multiply this number into 5. And FTCA Act, $40,000 per violation. So we have, the good part is we have so many tools and testing methodologies available to make sure our system is compliant and in line with the guideline provided by the regulatory bodies. We have different application security testing methods: IAST, SAST, DAST, and penetration testing. Let's go from the DAST. Test running application dynamically to find the runtime issues. This dynamic application security testing, it will make the application to run, and then like you start interacting with the application, and to get to see if there is any loophole to get through without proper authentication authorization mechanism. And static tool, SAST analyzer source, it usually scan the code. It's kind of static method, like scan the code and see if there is any vulnerability in the source code, then that will be reported. And penetration is very similar to DAST, simulates real-world attack for comprehensive security assessment. There are tools like Bob tool and others, stuff like they run the application. That penetration test users act like a kind of hackers with a hacker mindset and try to penetrate the system and go over the boundaries without proper privileges. And whereas IAST combines both static and dynamic, and for precise vulnerability detection. So these are basic and the security methods available in the in practice that can be used. Okay, I'm sorry, I realized my screen was small. Okay, so here are some like very general, high-level software lifecycle methodology and different phases of the software needs to go through before it reaches the production. And more than 90% of software development today happening in agile methodology, unlike waterfall methodology, right? Which is not practiced widely today. So usually, like to give background, so agile methodology or a scaled agile, they will take, instead of like trying to deliver the whole application software as a single unit of delivery, they take it as a kind of small chunks. Let's say I have to develop an application or system which would take 1 year. The idea is make it as small chunks. Like first quarter, I'm going to deliver, and second quarter, so I'll deliver the second 25%. And the advantage is the client feedback. If anything goes wrong, we need not wait until the 100% application to complete. But when we complete certain part of the application, we can get a faster feedback from the customer, faster feedback from the market, and we can able to quickly fix it, and then need not to spend whole over time to rewrite the remaining part of the application. So let's say like if there is that's called PA planning, and give more information to understand everyone in the same context. Now in the PA planning, let's say like PA planning consists of, let's say, 3 months. That varies based on every organization. Let's say if it is 3 months. So in the 3 months upfront, we'll make a decision. Okay, what are the goals we are going to complete, and the task will be like the scope will be broken down to a smaller task, and which can fit into multiple iterations. Let's assume we have 3 iterations in one first PI, and in which like we need to make not deliverable, measurable software, to demonstrate it. Let's this is how it works. Like in the first iteration, let's say every iteration takes 2 weeks time. Developers develop an application, simultaneously testers create the test cases, and if there is any defect, that will be fixed, and again it will be deployed and will be tested. So end of this first iteration will be ready, and on top of the deliverable, like iteration 2 will X+1 will take care, again same cycle, develop, test, fix, and deploy. This would go all the way until the one full PA completes. Once this is completed, it goes to other phases of security testings. Okay, the question is, the reasoning behind why it has to go after the fact is that historically we have a limitation, like all this SAS, DAST, ISAT, pen testing, those all need different skill set, different specialization, and we cannot afford to have multiple of these professionals in every team. Usually these teams work as a kind of shared services, because similarly there could be other tons of projects working, and they don't need to keep all the members in their team. Like they complete it, share it with them, they use their specialization skills, tools, and test them. If there's any vulnerabilities, they'll send it back. That's limit. That's a reason behind this. And the limitation is, let's say we tested the application and then again tested, again developed and tested. If there is any defect, the bugs, it will be taken care, again tested. When it go here, when the developer touches a code, the certification provided by the test engineers will no be valid because the code is updated. Again, this has to go through testing and deployment, and if there's anything you find that need to be fixed. This is kind of painful process, as you can see here. And the same thing applies. After this deliverable, test, pen testing, if there's anything, it has to go back here. So to avoid these challenges, to avoid this, time-consuming thing, like we can go with the tools and the technologies available today. We can go with kind of shift left strategy. For example, there are some tools in the next slide. I'm going to show you a bunch of commercial tools. It's not a promotion for those commercial tools, but just to give you awareness of what are the different tools available in the market, which can be leveraged by the developers to address the problem. And so as a part of this, again, some SAST, DAST, and ISAT pen testing can be completed in every phase of the iteration itself. Right. So we take care of it as a part of the every iteration. And when it goes here, we will have minimal or zero vulnerabilities. Then it is easy to pass. It does not guarantee that the shift left strategy going to help us 100% will be taken here. No, because the specialization, the tools, and the scale of the testing, what this specialized team is going to do, we don't want our developers to do it. But at the same time, it's going to save a lot of time. For example, I would say, like 60 to 70% of time can be saved by having the strategy. That's a big win. And this also helps kind of, cross-functional knowledge. So the language what DAST or SAST, or pen tester speaking, developer or tester working on the day-to-day development can able to understand. And when they develop itself, they can develop with that mindset, very defensive mindset, so that it will not get caught here and then wasting the time here. Okay, so here are the different commercial tools available, and it's very limited, but I have what I have provided, but we have more than several hundreds of tools available. So we need to make sure, again, this is not a commercial promotion of these tools, but these are widely used tools. So we need to make sure what exactly fits into your application, your pipeline. At the same time, and licensing cost and other reasoning in your organization, you need to find and make use of them in order to reduce the time we stuck usually here in the traditional way of time stuck here in the spaces. And this is not just a developer job, but also an important role of DevOps teams role is important here, because some of the items can be injected as a part of the build pipeline. So the developer need to kind of do it everything in his local machine. When he before create a pull request or merge request, the scanning can be done and then can be stopped over there. Whereas pen test and dash test need to be deployed, and it can be kind of need not to be just a developer, but also a regular functional testers also can able to cross train, and they can start working on making sure the basic components are taken care of. Right. So the conclusion is security is not a blocker to innovation. It's an enabler. By shifting left strategy, leveraging AI, and preparing for the future, we can deliver faster, safer, and more resilient applications. Thank you.
Thank you, Mr. Veeramani. If anyone has any question, they can raise their hand.